Good. Maybe another 30 seconds to a minute.
So Usman, I have some slides up too. Do you?
Oh, I think I'm just presenting the status and the introduction, and then it's over to you, Ken.
Okay, sounds great.
Okay, well, welcome everybody, the N3C Community Forum. And as you probably intuited or saw the schedule, Ken, Ben, Amor, and team will be talking about FHIR and the Tenant Model. And this is very exciting work that a bunch of us are very enthusiastic and in various different ways having discussions and plans, and it's all dependent on Ken and the team actually making it all happen. So that's exciting. And so things continue. 65 sites have released data in the pipeline, 270 sites, DOAs, almost 3 million COVID positive cases with 3 years of data, as I'm sure most, but not everybody on the call knows. This is really not just a large number of cases, but really I don't think there's any other longitudinal data set involving COVID of anything nearly the scale, with a total of 8.5 million folks. Okay, so that's what I'm going to share, and then I will relinquish the screen. And Ken, over to you.
Thank you, Joel. Try to. Can you all see my slides?
Yes.
Okay, great. Well, first of all, I've been looking forward to this demo for a long time, but more important things happened, but I really appreciate giving an opportunity to talk about quite a few things. For the community, what this is really about is a lot of work that we have done for N3C and prior to N3C, we can leverage in the future. And what I'm actually hoping to get out of this is a discussion of what we should do beyond COVID, and what can we do and what should we do. So just to move forward, I'm gonna, like I just said, this is really one to be a conversation. Nothing's promised, nothing's written in stone. It's where do we want to go as a community? We'll just talk a little bit about history of how we got there, and then Amor of Palantir will talk about terminology services and the tenant model, and we'll talk about a little bit more of that in a second. And then Raju Hemadri will talk about an agent model, and they're pretty exciting, and I think that they'll spark some interest in some conversations as we go along. There's going to be a theme that goes through this, and one of them is the importance of vocabulary and terminology in CodeMap Services. And Melissa and Chris and her team are on the call. Thank you for joining, because no matter what we do, I think this is one of the central issues or simple most important assets that we bring to the table. So let's talk about a little bit of history. I won't go into too much yawning information, but the point I really want to make on this slide is that we've been working on this a long time. When Rob Califf was the FDA director, Mitra, Raka, and I, and some other groups, but Mitra more than anybody, applied for something called an ASPE grant, or Pecori Trust Fund grant, and the idea is to allow all the common data models to talk to each other. What a surprise. And at the same time, or a little bit later, Sam Michaels was really planning on how could NCATS facilitate translational science better. And it wasn't just the Palantir enclave or the Palantir instance, we brought in many enterprise applications, whether it's a Google Business Suites or a Jira Suite, or the fact that the way we authenticate called Una. These were all things that were really planned in 2017, 2018. And of course, as we were planning these in 2018, 19, you know, we have 2017, 18, excuse me, you have CDMH2, sorry, CD2H, sorry, too many acronyms. And really that was, you know, Melissa and Chris and many other folks were, you know, trying to figure out how to make the CTSA act as a network. And as part of that cooperative agreement, just a reminder, it was the aim one was governance, and then after that it was data harmonization and interoperability, and then algorithms, best practices for algorithm tools and software. So, you know, you can see that a lot of these things were very much pre-pandemic, but we were able to leverage them to do N3C. And then we go a year later, and the CDMH2, the Common Data Harmonization project has second phase, where we're moving from harmonizing model to model to more of a harmonizing through FHIR. And this project, I'll talk about this a little bit more, but also keeps in mind CDISC. And then, of course, COVID hit, and all hell broke loose. And for the past 18 months, we haven't been really able to work on some of the CodeMap services that we had planned on, and CD2H and many other things. But what we did is we moved a lot of the infrastructure that had existed into our governance meetings on Friday. And then, of course, Hanfang is running the sandboxes for NLP, and Justin Reese and Peter Robbins that are doing machine learning and those in what we call sandboxes. And then, of course, Chris, as the data harmonization group, was what we were doing when we started off CD2H. So that's kind of where we are now. And the only thing that's really changed about that vision, and this is a slide that Mitra first, or pieces of a slide Mitra put together when we first kicked this off, is these, we used to refer to this as the adapter model. And Mitra went to Radio Shack, which doesn't even exist anymore, and got all these adapters and said, well, we should be able to go from any model to any other group, CDC or FDA or NIH, and you should be able to get it in the format you want. Now, we have added bulk FHIR because that's around the corner, but really this is kind of a long-standing project. And at the core of this is really CodeMap Services or terminology services. Today, we're going to talk about CodeMap Services, which I would refer to as a subset of terminology services. So when we first kicked this off, you know, what looks like a ball of string on the left was everybody was mapping to everybody else, and it was just not maintainable. So you work with NCI, we decided, some poetic license on this, but to map every data model to FHIR US core, and then to be able to map out to any other data model. So you should be able to go from common data model up to CDISC SDTM and submit directly to the FDA. And part of this idea was, with Denise Wazell at NCI, is that a source of truth of all these mappings would exist at and be curated at NCI. And for the folks who don't know this, they have something called Enterprise Value Services and CADSR, which are really an amazing resource that curates, put things in something called metadata standard 11179. And so we're really picking up on that. So we went ahead and leveraged, you know, when COVID hit, and this is the enclave that you all are working in. This is the enclave that Sion Michael had really planned many years ago. And as you know, no surprise, you know, you're working in the environment that we now know is in the N3C enclave. And just as Joel said, we've, you know, come a long ways. But all this work we did, and Chris's team, you know, took the mappings that we had done in CDMH1 1 and updated those along with another team called Sambit. But we can really go a long ways with what we did, and that's what I really want to talk to you guys about today. One thing I want to remind people, or at least make some sort of statement, is that there seems to be this false dichotomy between a centralized model and a federated model. I actually don't understand that. I actually think these are they're symbiotic. They both exist and do different things, and they actually overlap quite a bit. And I think it's a little bit of a, just false to seeing, are we going to do these federated or are we going to do the centralized? I actually think there's a hybrid of all this, and I think that they're both important, and in some ways there isn't a both. They're really just almost a continuum. So one of the things that I have been heard many times is that N3C is, it takes, but it doesn't give enough back to the community. And so before I hand it over to Ben to talk about the tenant model, I want to talk about something that I'm going to steal a phrase from Chris Shute, that we can use FHIR as what he used to refer to as a pluripotent model. So on the left, and I should step back, bulk FHIR is going to be a requirement through the ONC in something called TEFCA. If you aren't familiar with it, it's worth looking up. And part of that is bulk FHIR, unlike FHIR, is really population-based information. And so all EHMR vendors are going to have to be able to transfer data for interoperability through bulk FHIR. Well, it really opens up a lot of opportunities for us. As you all know, FHIR has hundreds of profiles. And right now, I feel like we're not taking advantage of a lot of the data that exists because of our own limitations. But right now, a lot of institutions, they get funding from Trinetics or PCORI or ACT. And so they set up these stovepipes where they pull the data out of the EHR and they clean it up, and then they make it for analytics in their model. And the problem with this is that, and what I've heard loud and clear, is that this is really expensive. I've got to have people do PCORI, I've got to have people do OMOP, I've got to have people ACT and Trinetics and Sentinel, and it just goes on and on. But if we use FHIR as the kind of hub, and with all the CodeMap services that Chris's team has worked on with Palantir and Sambit, is we actually could move things into a FHIR repository. Again, it's going to be required. And then we could export to the model that is needed. And let's call these the analytic models of OMOP, Trinetics, PCORI, or ACT or Sentinel. But we actually have the ability now, because of the things we've done, to, if we can give back to the institutions who've given our data, we could actually, I think we can reduce their overhead, maintain a single FHIR repository. And I'm going to talk about a FHIR repository that we want to float the idea of us hosting, called Smile FHIR repository, and allow you to convert it into the model of your choice. One thing I wanted to talk about before I give up the stage is that I did say that CodeMap services are a little bit different from terminology services. You're going to see this little daisy wheel, which is really this picture right here, throughout the rest of the presentation. And it is just a piece of mapping. And so if it was really, terminology services, we would have local coding, which is something we're working on, specifically called Shield Initiative with Loink. But there are other ones we could do with, and we would have Loink and ICD-9 mapping, RX norm, and value sets and FHIR definitions, and all of this would be stored and accessible through APIs to many services, including the mapping that we've done, which would all exist in the NCI. So I'm gonna, the expression is that you talk about something more than once and then people remember. So I'm gonna talk about what Ben is gonna talk about, and then what Raju is gonna talk about. And I hope that if we go over it twice, because I've been obsessing on this for 5 years, that it'll start to make sense as a proposal. So the thing that Ben's going to talk about is something called the tenant model. And the tenant model says that, and these pictures are supposed to represent academic institutions. You know, let's just say this is Duke and this is UNC and this is Texas. 3 words I can spell. And if we supplied a virtual private cloud, we being NCATS, and you could bring your data into your own virtual private cloud, meaning you, the institutions, controlled it. We, NCATS, merely hosted it. All the services that you now get through N3C, transformation, data cleaning, data quality, data lineage, granularity, de-identification, AI/ML services, codebook, analytic tools, all of those would be available to you in your data. And so you could use that data and use those tools, and we would pay for the hosting, is what we're thinking. And this seems like a pretty appealing deal to me. But we could take this a step further, where let's say that Duke and UNC decided to work together on work that was, let's just say, pediatric work. And so you guys, Duke, UNC, created their own virtual private network. You just created your own, and we allowed you to create it, and you could still take advantage of these services. In fact, Duke could bring it in as FHIR, and UNC could bring it in as OMOP, and part of those CodeMap services, that little circle there, would make sure that they were mapped, that you could get from one to the other, and that we would harmonize that data. But then Duke could say to Texas, you know, I want to work with you guys on hypertension. And again, that would be a virtual private cloud that you would set up yourself. And so the setup would look something like this. In the tenant model, all you're really doing is, unlike a DUR where you're saying, we want this to be reviewed by the data access committee, we really don't need that anymore, right? Because it's your network. And so you're going to put in a description and a title and, you know, the files that you want, who you're going to collaborate with. And this is obviously a cartoon. And then all this other stuff, DAC and letter determination, human subjects, you know, code of conduct, ID security, this is up to you guys. This is your network potentially, right? So whether we want to require those or not, they're really up to us. But minimally speaking, since it's your data and your network, actually we did not really have to. And we could set up many of these tenants. And in fact, if you stretch it, N3C is really just a big tenant. It just happens to be a tenant of over 65 institutions, but it's really just a large tenant. Then we're gonna, and that's what Ben's gonna talk about. And then I wanna talk about this other model that Raju's gonna talk about. And I'm referring to this as an agent model. And it is still using CodeMap service, but it's quite different, but it's still just a use case of what we're doing. So for those folks who don't know, this is a picture of Sputnik. It was a satellite that was launched by the USSR in many years ago and frightened us that we were behind the space program. So the reason I put this Sputnik up here is because there is a little Sputnik, which I refer to as an agent in this model, the agent model, within the virtual private cloud. In this model, again, just a use case of the same things we've done. Here is Duke again. They've transferred data into their virtual private cloud. Again, it's theirs. CodeMap Services cleans it up, does QA, harmonization. But in this model, you've got a partner, and your partner is FDA. And FDA says, we want to be able to run a query, and they potentially would be paying you for the network. Again, this is just hypothetical. And they would say, well, if Duke has I think I said PCORI, and UNC has OMOP, then a single query does not work because you know, you not only do you have to get the model correct, but you have to get the model version correct. You have to get the model version server correct, Oracle versus SQL. But if we could convert all of this to FHIR, which the CodeMap services can do, then this query called a CQL could be written by, we'll just pretend it's FDA, and given the permission of Duke, UNC, and Texas, that data would be pulled out of here as a data set. It would be harmonized, meaning, you know, we would glue all the 3 data sets together. It could be analyzed here. We could stick it in OMOP, But the CodeMap Services actually has the ability to send it to the FDA as an SDTM file, which is the format that they expect for submission. And with Nitra and Scott, we have practice going through the FDA gateway, and we can do this now. Pretty cool. And as FDA moves towards a more modern technology, and they will someday expect that they, accept the JSON file, not yet, but they have to go through a lot of things. We can do that too. So we're kind of ready to go. So suddenly we have the ability to participate in trials that are asking for regulated data. But because of the way we've set this up, and I know that there's caveats with 21 Part 11, and I won't get into that, but we have a lot of power that we could pull off. And this little Sputnik thing that I wanted to talk about, and this was up here to remind me, unlike the tenant model where Duke and UNC decided to work together, in this case, the data really is in your institution's virtual private cloud. And therefore, there's going to have to be a lot of permissions given to pull that data, or at least that's how we built it. And that means that if the query goes in, the institution gets to say, yes, I'm willing to let that data go. It gets to say, I'm waiting for the query. It gets to say, I'm going to transfer it this way. So what Raju's going to show you is a lot of the controls we put on to put you, the institution, in your own VPC to power, in control of your data. So with that, I'm going to stop sharing my slides, and Ben is going to talk to you a little about the tenant model and CodeMap Services. So I'm going to stop sharing. And Ben.
Great, thanks. Can you hear me?
Yes.
Yeah, thumbs up. Perfect. Okay, great. So let me share my screen, and we can take a look at what this might actually look like, at least sort of on the back end. So I'm going to start with a brief explanation of how does this actually work right now. So, for most researchers in the enclave, they come in and they see the nice sort of harmonized data quality assured OMAP tables, either the LDS or the de-identified, and that's kind of where they start. But obviously there's a lot of work that is happening before you get to that point to take the data from each of the sites, to harmonize it, to check the data quality and so on. And so that's what we're looking at here at a very high level. You can think of this as kind of a map of the flow of the data from on the left as it comes into the enclave from each of the sites, the payloads that they're contributing, passing through the harmonization pipeline where, depending on what data model it arrives in, it's transformed into OMAP, passing through the normalization steps, which is mainly dealing with the units, so harmonizing units, inferring missing units. Then there's all of the data quality checks that are applied before the data is marked ready to be released into the release datasets. So behind this harmonization pipeline, there is obviously a lot of complexity itself. And so I'm going to blow this out one step and think about this from the perspective of three different sites that are currently contributing. So some sites are providing data in the Trinetics data model, some in ACT, some in the CoreNet. And so for each of these, there is a template that has been created with all of the mapping logic to transform the data from that source data model into the OMAP target. And that template can be deployed very easily in just a few clicks. And this is what the data integration and harmonization team do, so that when a new site submits data, they look at what is the source data model, they apply the template, and that rolls out all of the logic, the actual ETL logic. But it also rolls out things like the data quality checks, the build schedules to make sure the data is kept up to date as new payloads arrived, and all of the kind of monitoring and data quality things that you need to make sure the submission is good. And all of that kind of just happens automatically as that template is deployed. So right now, that's being done in this kind of centralized way by the DI&H team, and it's happening within a sort of private space that's only accessible to that team. But you could imagine a world in the future where actually, when the data lands into the platform, it lands into a tenant that is controlled by the site itself. And then they, in a self-service way, can grab these different transformation templates and apply whichever one they would like in order to get the data into the target data model of their choice. And so to see a little bit more of what that looks like, I'm just going to give an example from the from Trinetics. And so really what's happening is, the data is coming in and it has these 7 different sort of domains that Trinetics uses, and it passes through this mapping process to land into a set of OMAP tables. And what we've also been working on with Raju and the team is a downstream transformation that will actually take the OMAP tables and pass it through a different set of mappings into a set of FHIR profiles. And so you can imagine having many of these different sort of templates that are represented by these boxes that are very easy to kind of grab, apply to your data, and get these kind of CodeMap services in a self-service way. So that's the first bit of things of how do we actually sort of take the data in from these different data models and apply various different mapping services to them. The second part of this is the tenant approach. So how does that differ from the current setup? So most of the people who have worked in the enclave will be familiar with the sort of data use request workflow. And so that's required before you get access to the harmonized set of OMAP tables, either LDS or de-identified. And it basically requires you to fill in a bunch of information about what your project is going to be looking at and why that's an appropriate use of the data and various other pieces of information. But of course, what you're really asking for is access to the whole data set across all 65 sites, because as Ken said, the current setup is essentially one sort of big tenant that gets you access to all the data. In the future, it might look more like this, where research project is a collaboration between 2 specific sites, Site A and Site B, who want to come together, who want to share their data so they can raise the size of the population they have and get better statistical power for their study. And so they're going to fill in a form like this. It can obviously be customized depending on what information they want to collect. And now you're actually specifying specifically the set of sites, in this case, just a simple example of 2 sites who are going to be collaborating together. And you could fill in things like the linked data modalities you might be getting through PPRL. And then you might also specify a specific cohort of patients that you're going to be using in this study. And that could either be a specific set of sort of patient IDs that's been previously identified, or it could be specific logic that has been created. And we'll see an example from Raju of how that logic might be defined using CQL. And then once this has been submitted, and whoever needs to approve this from Site A and Site B, and as Ken mentioned, the governance processes might look very different across different kinds of networks and different kinds of collaborations. What would happen on the back end is, flipping back to this sort of behind the scenes view of the data flow again, we'd have something like this. So you've got tenant for Site A. So this is a private workspace that's only accessible to Site A. Site A is an ACT site, so the data is being sort of synced into the tenant in the ACT format, and researchers from that site, if they want to use the data in ACT data model, they can just access that and start using it. Similarly for Site B, they've got their own sort of private workspace. They have data in PCORNet, and again, researchers can access the data in the kind of original data model and do their research. But now they want to work together, they need to do some transformation into a common data model. So they apply the CodeMap services to do that harmonization into a set of OMAP tables. And then they take that cohort definition that we were just describing, maybe it's a simple SQL query, it could be something more complex, to identify a specific subset of those OMAP tables that is just going to be used for this particular project. And it's at that point, as we go downstream into this research project space, that this then gets combined together. And we have a new private workspace that's only accessible to collaborators on this particular project. And all of this is being managed through the permissions and the access controls, such that if I look at this from the perspective of a Site A user, an admin user from Site A, you can see they've got access to everything up here in their tenant. They do not have access to anything in Site B, and they might not actually be a collaborator on this research project. But if I look at this from the perspective of Site B admin, it's the reverse. They can see everything in the Site B tenant, nothing in Site A, and nothing in the research project. And finally, if we look at this from the perspective of a researcher, well, they actually only see the data in the research project, just as you do now when you have an approved DUR, and they can't see everything upstream in the admin project. And so we can have these very flexible ways of creating these kind of dynamic cross-site collaborative networks and controlling access to that very granularly. And so finally, just to kind of give an example of, well, why would we actually care about doing this? And it kind of seems obvious, but it's nice to make the point very explicitly. This is an example of an analysis that's been done within the platform, within the enclave right now. And this is the Datos team at NCAPS, who have been developing models for mortality risk based on a variety of different comorbidities. And so they do some processing, and then they take their data and they essentially fit a Cox proportional hazards model to this using all these various different inputs. And this branch here is what happens when they run this analysis against just one site. And so if we look at the logs for this, we can see that at this one site, we had an N of 111 and 69 events across those 911 patients. And so if we look at the actual results for this model, and I scroll all the way down to where we can see the statistical significance, we can see we've got some of these features which look mildly significant, maybe a couple which have high significance, but overall, nothing interesting. If I switch this over to a model that I fit against data from just two sites, so just adding in one more, and I have a look at the same logs, we can see we've now got an N of 3,500, 307 events. And if I look now at the statistical significance, I can see many more of these covariates are being identified and flagged as statistically significant outcomes. And so we've increased the signal, we've increased the power of our analysis just by combining across two of these sites. So with that, I'm going to stop and hand over to Raju to talk about the CQL and the second half of all of this.
Thank you, Ben. Thank you, Ken. So like Ken said, we've been working on common data model harmonization from 2017 onwards, and we are currently on our phase 2. So this, what you see here is our common data model harmonization phase 2 high-level architecture. We talked, Ben and Ken also talked about how a FHIR repository could be provided at the Tenant Model. You could bring in data via multiple methods, either from your own FHIR repository, number 3 here, or bring in data as one of the common data model to FHIR, or you can bring in from EHR and do a data transformation, and through a secure data pipeline, you could bring them into the FHIR repository at the cloud. You see there are two different components here. The one on the right is what we call as an agency side components, which has a data aggregator and a data repository and multiple ways of exporting this data. One of the path is going as a CSV to NAH, or it could be also be what we are currently working on is adding another way to bring in the data in the FHIR format, the combined data in a FHIR format into OMA, just as how Ben showed a few minutes earlier. Or you can take the data from FHIR to SDTM to be submitted to FDA Gateway. These are all kind of like, if you think of as a hub and spoke, the agency is a hub here, which aggregates the data from multiple data partners. When you see on the left, the cloud, you can imagine this cloud being replicated for each site. There could be a site A cloud, there could be a site B cloud. So apart from just having a FHIR repository on the cloud, you'll have some additional components to be able to support a federated query. For example, if an FDA researcher wants to find all the patients who had a certain condition which occurred after taking some medication, probably like 60 days, then we could write a query to get the data. Now, each of the site, because they all have the FHIR repository, we could send one type of query. In this case, we're using CQL to send the query, run against the same model, so you don't have to write multiple types of SQL queries, get the result back in one format, which would be a file bundle, a series of JSON files that could be aggregated and transformed into one of these output formats at the agency side. The components we have here is mainly a query agent. Once the query is created and submitted, it goes to the data partner. When it goes to the data partner has a way to verify the query to make sure that it's not requesting data that's not supposed to be going out of them. So that's what the query agent on the top left does. It sends the query to the partner to approve. Only when they approve the query, it executes against the FHIR repository via FHIR API, series of FHIR APIs. And then the results go back again to the data partner so they can verify the result before they send it back to the agency. So this is our high-level overview from the CDMS Phase 2 architecture. I'm going to show you the series of slides about the interface that we built to build a SQL query and how this entire workflow works from end to end. Next slide, Ken. Thank you. I have a series of slides showing the portal. So this is our landing page for the portal. For the researcher, you have a login button. Just log in. Right now, we haven't integrated with any of the external authentication systems, but that's in works. Once you log into the screen, next slide, Ken. You would see a screen that just looks like on the top left corner. Again, this SQL builder and the process I've shown is we call it as a guided SQL builder, where you have a simple UI for you to be able to select multiple inclusion criteria or exclusion criteria and the parameters that would help you to build a SQL. So on the top left, it shows how you can add an element, and then the selection list of elements available for you to select. And once you select an element, then you can use the VSAC to authenticate yourself and get the list of conditions or codes that you want to use. Next slide, Ken. This is just some screenshots of how that could be done. Adding a value set or adding a code, you could do that via this UI. Next slide. Again, more screenshots of if you wanted to do an condition or out condition on multiple conditions or condition and encounter, you can do that using this option. And the same options exist for the exclusion criteria also, so I haven't really repeated those slides. Next screen, Ken. So what you see here is, the UI is okay for a beginner to start building the query, but much more complex queries, we give an editor kind of an interface, or more like a notepad kind of an interface for you to write your own SQL. You can save it. Next slide, Ken. So using one of these options, you can build your SQL query either using the UI or using the SQL query interface. Editor interface, you could get that, and then you see that the query you just saved is now available on the query manager. And you have certain actions that you could do. The green button submits the query to the subscribed data partners. When I say subscribe, there could be multiple data partners available, but for this purpose, maybe the agency only has data use agreements with only few of the sites. So those are subscribed data partners. When you do a submit on this, the data, the query request actually goes to all the subscribed data partners. Next slide, Ken. You see that one of the data partners subscribed receives an email like this saying that, hey, now you have a task. Do you want to review this query and approve it? They can either approve or deny it. We're going to go with the happy flow. say that it gets approved. This is the process of approving. They would log into their data partner side approval process. You can accept it here and then submit the query. You can also see that on the right, there is an option to view, download the query. Next slide, Ken. So what happens is once the query approves, like I said, the series of FHIR API queries, the SQL gets converted into series of FHIR API queries. They are sent and run against the FHIR server, FHIR repository that's set up, and then the results come back as a file bundle. When in these results, again, initiate another workflow to the data partner, someone who is responsible for approving these results. They get an email. In this case, it could be set up on many other notification tasks as well. But we're just working through a simple use case here. Next slide, Ken. Same thing, they can review the results and they can accept the results to be sent to the agency. Once it's accepted, the agent installed on the data partner would take care of sending this data to the subscribed SFTP server that's set up on the agency. Next slide, Ken. This slide just shows the SFTP file that's sent across to the agency side SFTP server. From here, there is a workflow that picks up this file and processes it automatically into aggregated server. In this case, we are using MongoDB and Mongo database to store those results and then do further transformation and harmonization to get into an aggregated format. Next slide, Ken. It's just a screenshot of showing how the results are stored in the MongoDB. You can see that it's stored by resource type, and for each resource, there is a row existing on this database. Next slide. So once the results are back, you can see that the results are sent to multiple data partners. Let's say in this case, we only got result back from site A. We receive a partial result. You still have the capability to view that result, download it, and then just view it because these are all JSON files. You can view them, or you can select an option to generate SATM, which could be submitted to FDA gateway later on. Next slide, Ken. So once you were able to create that SATM, you can use the SAS viewer to look into the file. In this case, we generated a couple of SATM files, one for demographics. Next slide, Ken. And then a trail summary file that's essential for the submission to go through FDA gateway. These are some of the slides I put together just to show how this agent model works. Back to you, Ken. Ken, you may be muted.
I'm sorry. Thank you, Raju. I was talking to myself. We put together a lot of tools and services through N3C and other initiatives, and I just was hoping that we could open this up to, how can we leverage this stuff to help the different networks and different groups work together. And I think I just open this up to see if we have any questions. Before I do, Melissa or Chris, since the code services, CodeMap terminology services are so core to this, is there anything that you wanted to say as Vulkan or OMOP or HL7 and OMOP work that's going on? I know that's something that you all are working on a lot.
Well, no, you're quite right. I think terminology services are at the core of much of this, not just for code mapping, but for facilitating the common use of terminology resources with minimal overhead. DeVere, as you know, is working very closely with the Odyssey community as well as the FHIR community. And we, Melissa and I think it's safe to say, both see the terminology services as central to many of the grants that we're on. Her Phenomics First grant, the NCI grant we have for the Center for Cancer Data Harmonization, as well as CD2H. And it's also at the center of Win-Win, which was our RTD2 proposal that architecturally is very similar, Benjamin, to what you presented as a sort of a tenant model, a dynamic tenant model for protocol specific integration. So yes, I think terminology services are core. What's changed in the terminology services world in the past 3 years or so is the emergence of LinkML as an enabling technology and infrastructure that tremendously simplifies and is highly scalable and dead simple much of the effort and resource around terminology services. So I'll stop there and see if Melissa wants to add something.
Yeah, I completely agree. I think one of the really exciting things that we've been working on with the Odyssey community also in particular is just, there's a lot to unpack in those little wheels that Ken showed. And I think, computationally, one of the things we'd really like to support is better provenance and evidence for those mappings, as well as computational rules for deploying them so that users can pick and choose different types of mappings in the future where relevant to a particular analytical question. And so that's something that we've been working on in the context of our terminology mapping services, our CodeMap services, and also in the context of LinkML's support for enumerations in that context. So I think it's a really exciting time. We originally had hoped to do this work under the aegis of the Health Open Terminologies group to try to create interoperability in terms of the structure of the terminologies so that the mappings could be more robustly captured. But in the absence of LinkML back 3 or 4 years ago, we were really struggling to do that. But now that the LinkML modeling language has matured, we're really in a different position to realize some of these goals now. So it's a very exciting time for terminologies. Woohoo.
And that's a very rare thing to say, exciting and terminology in the same sentence.
I beg to differ, Ken, but that's
I want everybody to know that we are running a pilot with what Raju has done with University of Iowa, University of Indiana, and University of Chicago, University of Illinois in Chicago, sorry, on the more agent model. But we are looking for people who would like to test the tenant model. Again, that's would be your virtual private cloud. But if I wanted to make sure that also I said that, NCATS tries to be data model agnostic. And so we should be able to go from any model to any model, and any model should be able to be the analytics model. So I know that we've talked a lot about Odyssey. Obviously, there's various reasons for that because of N3C, and we had to choose something for COVID, but that's not the goal. The goal is to be truly NCATSian transformation, translational, and to facilitate wherever people are, where they're at, in addition to helping improve local data. So I don't know, I want to make sure that we open this up to any questions people have, or comments or rocks or anything like that. No spitting. Does let me and maybe I'll put a couple people on put people on the spot. Warren, what maybe from your point of view, putting on your NCI hat and now Duke hat, is this something you think that could be useful to the CTSA at large, or the greater, we actually, work obviously with CTRs, CTSA and CTRs. Warren, you're on mute if you're listening. Or anybody else? No. Well, then I guess we're coming to the end. I really appreciate everybody's send me emails if you're interested in playing. We've worked very hard on this, and we think that it offers us a really a way to leverage what we've done, like we said. And I'm repeating, I hope you heard this, is that part of the experiment is that NCATS would host that SMILE CDR, that SMILE repository of the FHIR repository to test this out. So thank you. I see Mary, thank you very much.
Well, thank you. This is very, very, very exciting.
We'll give you 9 minutes of your day back. Thank you, everybody.
Okay, thanks.
Thanks, everyone.